Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be learning how to calculate the mass moment of inertia of a rectangular plate with the dimensions a by b by t, the thickness is t, about centroidal axis, centroidal x, y and z axis. So let us see the first case. Let us consider the rectangular plate with the dimensions a by b, and let us draw the centroidal axis, that is xc, and select the element at a distance of y from the central x-axis, and elemental thickness is dy, and write the expression for the moment of inertia, that is ixc. Ixc is equals to, it is integral y square dm, where dm is elemental mass. So this elemental mass you can write down, it is integral y square dm is rho into the density into volume of the element. Volume of the element is, it is this dimension is b and t, bt dy. So it is bt, it is dy. So these are the dimensions. Now you can write down, it is you can keep rho outside, bt also outside, where rho is the density, right? So integral, it's a y square dy, where the limits of integration are, let us see that it is minus a by 2 plus a by 2. So the limits of integration minus a by 2 plus a by 2, and this becomes y cube by 3, and you can rewrite this as 2 into rho bt. You can write down integral 0 to a by 2 into this y square dy, and this becomes y cube by 3, and you can write down 2 by 3, you can keep outside rho bt. This becomes y cube, means it is a cube divided by 2 cube is 8, and you see that it is 2 4s are, and you have 12. It is, you can write down rho into bta, bt, it is bta, that is the volume of the plate, into a square divided by 12, and this value is m a square by 12. The moment of inertia about the centroidal x-axis is m a square by 12. So let us see the second case, that is moment of inertia about y-axis. You have calculated x-axis, and it is integral, it is I by c. You are calculating about the y-axis, it becomes the distance is x, at a distance it is integral x square dm, and this you can write down, it is x square into dm is rho, volume of the element. The volume of the element is dimensions, observe carefully, this is at into this dx, so at dx, and you can keep rho at outside, and this becomes it is x square dx, and the limits of integration minus b by 2 plus b by 2, you can write down 0 to b by 2, and you can multiply with 2. So now you have, it is x cube by 3, and substitute the limits, that is 2 by 3, it is rho at. So this b by 2 whole cube means it is b cube by 2 cube is 8. So it is a 2 4s, and you have rho into ATB into B square divided by 12. So this is nothing but mass, density into volume of the plate is mass, and you can write down this is MB square by 12. Your IYC is MB square by 12. This is MA square by 12. And to calculate ZC, the moment of inertia about the z-axis, you can apply perpendicular axis theorem, and IZC is equals to IXC plus IYC, and this becomes, it is M by 12 into A square plus B square. This is IZC. So you have calculated the mass moment of inertia of a rectangular plate about x-axis, about y-axis, as well as about z-axis. Thank you very much for watching this video.